Hello everyone, my name is JP McGon, and today I'm just going to do a simple tutorial on how to load the airfoil coordinates into Solidworks. So without further ado, I'm just going to jump right into it. So first and foremost, to get your coordinates, you're going to go to airfoiltools.com. It's a common website just to obtain the coordinate files that we're going to be kind of manipulating a bit to get it into the Solidworks format. So if you already have your airfoil in mind, you can go to the airfoil search. And if you're just looking for an arbitrary airfoil to work with in design, you can kind of go off to the search to the right here. And you can kind of specifically look. There's actually a list of all airfoils, so you can click that link. So for purpose of this, I'm going to be showing you a supercritical airfoil that I've selected. So I'm going to be choosing the NASA supercritical phase 2 airfoils, the 0414. So what you can do is once you find your airfoil, you can click on the graphic here. You don't have to. This is one of the ways you can do it. You'll see there is a DAT file that is listed here. To download the source DAT file, you can just right-click here and save link as. But for the purpose of SolidWorks, you don't really need the pure DAT file. So you can just copy this whole list of coordinates and put them right into Excel. So you'll go to Excel, workbook, and you're just going to paste that into the first column. So now you'll notice is that when you click on like one of these files in the A column, that's the coordinates are kind of all jumbled together, and we don't really need that or want that, especially when trying to separate them. So what we can do is click the whole first A column, go to data, click text to columns, click the delimited button, next, click space, next, and finish. And what that's going to do is it's going to kind of separate them all into nice columns that you can work with. And it will usually kick out this first number, but that's no worries. You can just add that, sort of paste it there. We can delete this first column there. And now we have our X and Y coordinates all organized. So one thing to note is in SolidWorks and in the event of this website, Airfoil Tools, sometimes the coordinates will be out of order. And what I mean out of order is that you'll see here is the coordinates will start at the leading edge 0, 0. If we scroll down here, it'll go to the trailing edge. And then all of a sudden there's this gap. Sometimes there's not a gap. Again, each of these coordinate files are a little bit different. But this is the upper surface, and then you'll see it jumps all of a sudden. It goes from leading edge to trailing edge of the lower surface. Now, SolidWorks needs to read a continuous smooth line for it to be accurate. Now, so in some events, you might need to separate the upper and lower surface. And for that, you can load these coordinates in separately with the method that I'm going to be showing momentarily. But if you want that smooth curve, it's ideal that you order them in that smooth manner. So to do that, what we're going to do is, in the event of this one, I'm basically just going to invert all of this upper surface so that it creates a smooth line from the, I guess it would be trailing edge to leading edge and back to the trailing edge. So a trick you can do to do that is just kind of make a series of numbers ordered, drag that down to the location of where you want to invert your coordinates, which for me, it'll be right here. And then what you can do is go to Home, Sort and Filter. Actually, just make sure you actually select this whole region. And then you're going to do largest to smallest. What that's going to do is, again, reorient your coordinates so they're in the proper order. So again, not all Airfoil Tools coordinates are like this. I know some of the NACA ones have been adjusted, but some of the more niche ones need to be adjusted properly. So make sure you take out any of these weird gaps as well. It needs to be smooth, and any repetitive points like this and origin are at the end. So now we have a nice smooth curve going from one side of the airfoil to the other with no discontinuities. So next, we are going to need to apply a scaling factor. So SolidWorks, when you load in the coordinates, it will read this in millimeters. I don't know why it does that. I guess it's just like its default. Some other tutorials that you see on the internet will show them just uploading these coordinates in millimeters and then applying like a scaling. I'm not too much of a fan of that. I think it's a little bit easier just to apply a scaling factor in Excel and kind of shift all of your coordinates to that scaling factor. So when you upload it, you don't have to worry about manipulation. Granted, if you need to do more hardcore manipulation, you can learn that other technique, but just for simple analysis, we're going to go with this method. So right now, this is reading technically 1 millimeter. and this is 0.0033 millimeters. So we're going to scale that up to 1 meter. So what I'll do is I'm just going to apply a scaling factor of 1,000, bring that again to a meter. There's a more efficient way you can do this with some of the semantics or syntax in Excel where you don't have to multiply it all the way down. But yeah, so what you'll do is you'll take your x coordinates, multiply it by your scaling factor, and you'll do that with your y coordinate as well. So this runs the scaling factor, and you'll drag this all the way down towards the end of your list. Perfect. So again, this will be technically 1 meter, this will be 0.99 meters, and so forth. That your y coordinates as well. Perfect. And then to make your final adjustment into SolidWorks, what you'll do is you actually need to add a z coordinate. So because we're making a plane, a surface plane, one two-dimensional only, you can just add zeros all the way down in this column here. And that's pretty much all you need for your setup. Again, you can do more manipulation with this if you need to, but this is the general process. So now that you're all set up, you can copy all of these. So open up a text file or a notepad. We'll just paste those values right in. If it looks weird, like say there's like a tab here or something looks out of place, don't worry, SolidWorks is smart enough. It'll actually adjust for that and it'll pick up the coordinates, no problem. So then you will save this as whatever file you would like. So I was working with this previously. As well, just start with the file. And this was a NASA so save that. And you specifically want to save it as a .txt file, because that's how SolidWorks will read the file. So we'll save that to the folder. Open up SolidWorks. Always a fun time trying to get this program to load, depending on how fast your computer is. Perfect. So then you'll go to create a new part. Perfect. You'll go to insert, curve through XYZ points, and you'll browse and specifically look for it's going to be default curves, SolidWorks curves, so you can just switch that to text file. Click on your text file you just created, and you'll see here again that it does open in the millimeters. So again, that's why we use that scaling factor just for consistency. Click OK, and you'll see you now have a airfoil curve that it is created for you automatically. Now, one thing to note is that you'll see here that the trailing edge is open. There's a couple of different ways we can deal with that. First, we need to actually convert this into a sketch. So we can go to sketch on the front plane. That's where the coordinates are located. And then what you can do is go to convert entities, click on that curve, and you will have a line that you can work with. So we'll examine that. And then in order to work with this a little bit more in detail, whether you want to extrude the body or convert it to a solid surface, you actually do have to work with this trailing edge region here. So depending on the application that you're going to be loading this file into, it might be favorable to make a zero thickness trailing edge, like in the event you're working in ANSYS. I know the design modeler prefers, or like when you're going to do your meshing and whatnot, it's really good to have that zero thickness trailing edge. So in the event you wanted to do that, you can manipulate your coordinates a little bit and kind of create a zero thickness trailing edge. Again, that's kind of like a trial and error type thing. Or you could technically just kind of extend things out a little bit and maybe add like a fillet to these edges to kind of make it a little bit easier and a smooth transition. But for the purpose of there we go. For the purpose of this video, we're just going to add a thickness to it. Again, you can adjust this in anything you want. So we're going to close that like so. So now we have a closed body. And then from here, you can do one of two things. You can work on extruding it. So like if you want to make a wing, you just extrude that body. Again, this is all in millimeters, so you can probably switch it afterwards. You can make a wing body like this and then upload it into some type of CFD program, or if you're just trying to make a wing to model. The other option is you can here. You can actually create a planner surface. So for the surface, you get a planner. It'll detect your sketch, you click OK, and then you'll actually have a surface body you can work with. So this is really helpful. This is where you would actually upload this into a CFD program. Just one thing to note, that when you go to save this file, make sure go to desktop real quick. Yes. Make sure you save this as a not a part file. Make sure you save it as an IGS file, and you'll see why. If technically ANSYS and some of these other programs can read SolidWorks files, but a universal part file or surface file is the IGS, which makes it a little bit more cleaner in the transfer over. So from there, you can save it and then kind of upload it into your program of choice. But nevertheless, whether it be for design or just curious on how to do that, this was the process on how you get those coordinate files in the proper format and how you upload them into SolidWorks for more manipulation. In the future, I'm going to be working on a couple different videos on how to like explicitly upload the coordinates into ANSYS, because again, sometimes this method is a little bit finicky. So stay tuned for any other videos on that, and thank you for watching.